Hi everyone, welcome to the stream. Today I will stream my sort of C++ course session. And as usual, I'm streaming on 3 different services on YouTube, Twitch, and Watchable Code. And I will be checking comments on each of them. So please send me your questions, your ideas here to the side. I will be checking every chat, but the main one is going to be on Watchable Code. Random question: did you use Debian when you worked at Yandex? Well, on my laptop I did use Debian, but Yandex mainly used Ubuntu and FreeBSD. So, but people were free to use whatever distro they liked on their laptops. After that I switched to OS X because, well, I could, and so I started using OS X. But before that I have been using Debian for like 5 years, and that included using Debian and Yandex when I was working on my laptop. So let me close that. Oh, the hell is good. So sorry there was no stream on Friday, but this is because there was this sort of stream like a talk show. So I'm pretty sure that Thomas Marshall saw this, but for other people you can watch the recording. It was pretty fun. I recommend watching it, well, because I feel like it may be fun. We just talked with Mike Conley, who is a Mozilla developer. He works on Firefox, and we discussed a lot of interesting things. And it seems like people like that, so that's great. That's why I'm recommending it. I'm also interested in what you think about this. So, what question would you be interested? Like, what kind of? Yeah, I noted that. Thanks for posting it. It's definitely nice to see that it got lots of love from Redditors. Yeah, basically, Thomas Marcel extracted a piece about binary blobs. He posted it to R Linux, and so this subreddit liked the video. It got like 100 upvotes or like 150 upvotes. Let's go. My plan for today is to talk a bit about copying objects and then do some tetris development. I have no idea what I'm talking about. Yeah, there's definitely necessary some sort of ban mechanism, but normally people don't write crappy shit here. Okay. So maybe I should implement a ban mechanism here. I wonder what would be the simplest way to ban this dude. So why did you came here? I mean, it would be super simple to just ban people who are not signed in. Okay, so not that. Okay, so please shut up, or I will have to ban you. The worst part is that I will have to implement this. So shut the fuck up, please. You are not welcomed here. Type for R. My plan for today to talk about copying objects, or maybe ban this fucking weirdo. unless he voluntarily gets the fuck out of here. And after that, I'm going to talk a bit about copying objects in C++, because C++ is kind of low-level language. And during the previous session, I talked a bit about references and pointers and the difference between them. And so today I want to talk about copying objects. I never really touched the topic of copying objects. And yeah, so what about objects? So as you know, in C++, there is... Okay, no, I'm not going to ban him properly. He got quiet. Okay, so yeah, I talked a bit. Yeah, that's from previous session. Yeah, and yeah, so okay. So why the fuck you did just came here? Just get the fuck away from here. I guess I shouldn't be angry at my viewers. And normally I'm not angry, but you are not being very kind to me. So let's talk about copy demo. Let's create that, and basically basically, okay, as you know, there is special functions called constructors, and as I talked a bit about how compiler generates something like called default constructor, and like the default constructor is a constructor that has no arguments. So again, I'm using a bit synthetic example. So the default constructor is the constructor that has no arguments, and well, so for example, just does this, and so okay, when you create objects, you can then print stuff from there. Didn't work for some reason. Let's actually capitalize this. Oh, of course it's for private. Let's make it public too. Okay, so this should work now. Hello, I have a question. What is your preferred library to test code in C++? When I worked in Yandex, we used there was some testing system that was built in-house. So I used it, and well, outside of Yandex, I never really coded a project big enough to warrant a lot of testing. I know that there is like one of the simplest libraries is probably Google test C++ library. I know that there is it's pretty simple, and it's good enough for simple unit tests. And if you need a library, I would look at this library. So yeah. Okay, so I think Boost also had something. I'm not sure. Boost test. I'm not sure. I mean, there may be some boost testing library. Yeah, I'm not sure if it's any good, but I've actually used like Google's library once or twice, and it's pretty neat. Okay, so okay, so what? But okay, it's a bit synthetic example, and um, no, I don't know that game. So there is another type of constructor which is somewhat special. Basically, we know that if that sometimes compilers generate this constructor, and it happens when there are no other constructors. Um, Actually, I need to check this. Maybe. Okay, so what about copying constructors? Sometimes we need to copy objects, right? So if we create another object, like let's call it full copy, and do this, we need something called copy constructor that basically copies an object and using the contents of another object. And there is such a constructor. Basically, it's a constructor that you can call like that. So typically, typically it takes a const reference, but sometimes reference. So typical copy constructor looks like that. So it's defined like that. It takes a const reference. But I think I should talk a bit about const and non-const. Basically, const. Well, I don't want to get into too much details, but const objects are const. You can't really modify them, or I'd rather say you shouldn't really modify them, although sometimes you can do it. Normally, you shouldn't modify them. You set another variable 42, call the text in public side in text. Okay, yeah. So let's make sure that this function is actually called copy constructor. So copy constructor takes a reference to another object of the same class. And as you can see, it's being called. I think I should prove to you that. Yes. So basically, I need to prove this. Before copy, and after copy. Oops. And as you can see, here's copy constructor called. Now this actually does nothing, and we should probably actually copy the contents of this object, right? So we should do something like this, something like that. We should actually initialize the object, right? So the good thing about C++ is that it generates a lot of stuff for you. It does a lot of stuff for you. It's pretty low-level language. It gives you a lot of control, but it's still simplifies things. So let me check chats. Can you tell us what you're doing at this moment? At this moment, I'm just trying to explain how to use copy constructors. So I'm just going to create this really simple demo, either called a stack or queue. Um, so when do we need some copy constructor? By default, compiler can generate one for us, and it typically works as you would expect. So if it's built-in types, it just copies them, and if it's if build has a built-in type, it just copies it binary, and if it's some sort of a class, for example, if it's vector, vector is a bad example. If I remember correctly, it has no copy constructor. So, for example, if it's to this string, it calls its copy constructor. I guess I should explain it maybe more clearly. So, if you have questions, just let me know. I will be happy to explain this. So, in a lot of situations, you don't need to define this. You don't need actually to define it because a compiler is going to generate one for you. But sometimes you do need copy constructors. Okay, let me show you. Let's remove this. Let's remove this as well. And let's code a really simple class. I don't know. Maybe let's call it. Let's call as stack of integers. Right, so something really simple, and it's going to have some really simple interface. So let's actually allocate memory manually. So or maybe not. Let's actually use a vector. If I remember correctly, vectors have no copy constructor. Let me check this real quick. I may be wrong here. Okay, I think I'm wrong about vectors not having a copy constructor. Yeah, of course vectors do have a copy constructors. Do they have? Okay, I'm wrong here. Guess why wouldn't they? Okay, let's actually call this stack, which will work sort of like vector, and it will allocate memory manually. So here we're going to store a pointer to integers. All right, let's call this mem, and it's going to have a size. That's all. Okay. So by default, stack is going to be empty, and we need to allocate memory from heap. Last time I told that there are two main ways to allocate memory in C++. Well, there are other ways, but basically you can either allocate it on stack or on heap. And I mentioned that you shouldn't, and I mentioned that when you allocate memory on stack in some function, when this function exits, this memory shouldn't be accessed anymore. So you need to copy objects around, or you should allocate memory on stack. And well, I hope this makes sense. And here's how you allocate memory and stack. You just actually we don't really need here. Okay, let's create max size here. So let's say we want to create a stack that that can hold up to max size vector. So here's how you allocate an array of integers of size max size. Okay. And we are going to create a stack that has two simple methods. First one is going to be push, which pushes things on top of the stack, and the second one is going to be called pop, which just pops it from the stack. Again, something really simple. So they are going to increase size, and we're just going to do this. We're going to put this on top of the stack, right? And when we do pop, we just return something like this. Actually, wait a second. What the hell did I do? So we just take the last element. Actually, wait a second. We do this in this order. So we take the last element on the stack. We decrease the size of the stack. This is called elem now. This, by the way, can be written as a single expression, and then we just return it. So the next thing, so basically that's how it works. Let's test this thing. So we have a stack, and it's had a really simple interface here. What the hell? Okay, of course we need to provide max size, and let's make it 100. You can push things here, there. Oops, it's not push back, it's just push. Alright, and then we can, when we pop the things from stack, they're going to appear in the reverse order, because that's how stacks work. So it's pretty simple, right? But so let's just test this. And actually, let's add something like get size. Okay, so as you can see, it was 3, and again, it printed everything in the reverse order because it's a stack. And then again, the size of the stack got 0, and basically there is no boundary check. And it's just some simple test. I just want to show you why sometimes we actually need to define a copy constructor, right? So what happens if we decide to copy the stack? Like, let's make a stack copy. Let's create a function called copy demo, and let's call it here, right? Let's print some stuff here to delimit everything. And let's create a stack here of size 100. So let's put some stuff here. Let's put there 50, let's put there 60, and let's put there 70. And let's put there 80. So then we can copy it, right? There is still an automatically generated copy constructor. So we can just create a copy of the stack, right? And let's make sure that the size is the same. So let's print stack size. Oh, it's get size. Maybe I should have called it size as supports STL does. Okay, so it says 4 and 4. Now let's make sure that stack copy prints, like this should print 80. Okay, now let's make sure, let's print sizes again. Let's see what happens. And actually, did it just copy properly? Oh, okay, yeah, it did copy properly. So okay, it's less cool demo, basically. Okay, let's do this. Actually, I can still show you. Okay, I thought I forgot. That's not how we demonstrate. So let's put another thing. So it's seemingly it works, right? So the sizes are different. So let's put push 90 here into the stack copy. Okay, let's see what happens to the size. Again, seemingly it works, right? So let's try doing stack pop here. So we take the original stack and we print that, right? And as you remember, we didn't really modify the original stack after the initialization, right? So here we just do some printing and we modify stack copy, right? So this should still print 80. Should print 80. Okay, let's see what happens. Oh yeah, but it prints 90. And the reason why this happens is because this pointer is being copied as pointer. And as I mentioned, pointers are just like integers. Basically, they just hold an address, and we can get its integer value. Let's for a second, let's make this public, and let me show this. So stack mem and stack copy mem. Turns out that they share the same pointer, which is bad because we actually need to copy this. Again, this is a really simplistic example. I think it could be implemented using vectors. And so it's pretty simplistic. But let's say if we implemented an actual STD standard vector, we would have to do pretty much similar things. So, oh, hi. 6 people are watching on YouTube. That's nice. Thanks for watching. So what should we do? Again, the example is simplistic. There is no error checking. I'm just trying to demonstrate the points. But vectors are implemented really similarly. They do a lot of resizing, and they resize their buffer and everything. And there is a lot of things are going behind the scenes. But actually, the kind of copy constructor is going to look similar. So what do we need is to define our own copy constructor, because the copy constructor that is generated by the compiler copies pointer as a pointer, which is just an integer, and we actually need to copy memory. Okay, so what should we do? Okay, let's define it. Like I mentioned, a copy constructor is a constructor that takes an instance of the same class. So we are going to take it by reference and by const reference. And I'm actually going to demonstrate an interesting property of copy constructors soon. So we have an int const other, right? So here we need to do something. So basically, let's take a look at size, and size is just going to be like other size, right? So we just copy the size. And we again need to allocate the same, and actually there is my max size. Let's copy this as well. Again, these are just two integers. We can copy them just fine. They are not being shared, but the actual memory needs to be allocated again. And so yeah, let's allocate it. Oh, wait a second, and we didn't really store max size. And damn it, I should consistently name things using some consistent conventions. So I guess let's rename everything. Let's basically capitalize everything because that's how I like to name things. I just sometimes forget to do so because I have been writing too much Python lately. So max size. So we're going to have max size capitalized, and let's capitalize size. So let's make capital A as here, capital S here, capital S here. Right, okay, lots of compilation errors. Okay, let's capitalize here. And there is no max size, but okay, let's add max size here. So, what the hell? Max size right here. Oops. And let's rearrange everything. Okay, 21, 21. Okay, again, let's capitalize the first S everywhere. No member. Okay, let's make sure. Okay. Is this sidebar to your Vim plugin? Yes, it's a plugin. It's called Nerd Tree. It's called Nerd Tree. Have one on YouTube. So you're welcome. Yeah, I actually streamed a bit about my Vim RC development. Well, not really development. I just streamed myself configuring a Vim. So what do I need to do? Well, I wanted to share my Vim config with you. So if you're interested, there is my Vim RC. And you can basically take it and use it. It's not, you can't really drop it in because some plugins require configuration. For example, I have this nice thing called power line. So as you can see, I have a cool status line here, and it's really cool in my opinion. It looks very sleek, but it requires special fonts. So like this cool triangles require special fonts. So again, so you can't really drop it in. You need to install plugins. I recommend Fundle or Vimplug, but you can look at my VimRC for inspiration. Okay, so what do we have? Okay, so we not really modified anything. So we just need to execute this code, and as you can see, the memory is now different. The problem here is we now copy memory, but we actually need to copy values. Oh, sorry, we don't copy memory. We just allocate a new memory, but we actually need to copy stuff from. So let's just write a simple loop. Shorter way would be using. So we could use mem copy here. But I'm just writing a simple loop, just in case there is a cool function called memcopy. Plus I. So we have two chunks of memory, and yeah, as you can see, there shouldn't be this shouldn't print 0. So mem I is equals to other mem I. Oops, this should start with capital S. Okay, so as you can see, there are two different pointers, and as you can see, both of these lines print 80. So let's just make sure that top elements. Let's just make sure that I'm not lying to you, and basically this is going to print 80, 90. Oh, why did it print 70? That's surprising. Oh, it should print 70. Yeah, makes sense. Because we did pop 80, so the next element is actually 70. I forgot that we popped 80. So, yeah. So as you can see, sometimes it's necessary to define a copy constructor. So yeah, basically that's what I wanted. Oh, another cool thing. So for example, when you define a function and you make it with one argument or several arguments or whatever. So basically one of its arguments has some sort of type. Yes, that's what I'm trying to tell you about. Basically, there are multiple ways of passing an argument, but if you just type in stack, it will call copy constructor. So what is the best way to show it? I guess let's set some debug output. So let's just print here copy constructor. And let's print some delimiter here, and let's demonstrate how passing arguments work. Out stack size. Let's actually call it. Let's give it meaningful name. Print and pop. Right. So it's going to just print the last element. So have this function that actually has some sort of meaningful name. Well, actually, it's not exactly meaningful. You're going to see in a moment. So we have a stack here, right? We're going to create it, and stack size. Oops, it's called get size. Should have called it just size. Okay. Wondering why is it empty? Oh, yeah, it's because it's empty. Let's just remove this. There was a copy demo, but now we have this stack with 3 elements. So, by the way, let me just comment this everything out. Off-topic questions are fine. If you have like off-topic questions about C++ or programming, just ask me. I will be happy to answer them. As far as I know, yes, Clang is the default compiler on Mac OS X. And what's funny is they define G++, right? But it's also Clang. I mean, right? So I call it G++, but it says Clang error no file input files because it's basically G++ is basically an alias for Clang++ with some extra flags. So that's actually a funny thing about OS X. So let's just reuse this step that we defined earlier in the stream. And okay, so we have this print and pop function. Okay, so this says 44, right? And so here's the demo where the demo begins, and just print some delimiter. Then it prints size, which has 3. Yeah, basically I'm just talking about copy constructors. I'm not going to talk about move constructors today. They are actually C++ 11 thing. So maybe later we'll talk about them too. But today I'm just talking about copying, and I'm continuing to talk about references and pointers. So we have a copy constructor. The size is 3. The copy constructor is called pop and print and pop function just prints 44. Then it exits. Okay, so and then stack and size get size prints again 3. And this is because when we define function like this, when we declare it like this, it just copies object. Sometimes it's called pass by value. In C++, we also has references, and references work differently. Like I mentioned during the previous stream, they do not copy an object; they just give a new name to the same object. So, as you can guess, the output should change. There should be no copy constructor, and this should print 2. Right? So again, no copy constructor. It prints 44. and this thing prints true because it's the same stack that gets modified. It's not a new copy of stack, not a new instance. So yeah, we could also do this. We could also pass a pointer to stack, and it would work pretty much like passing reference. Like I mentioned, there is a difference between pointers and references. For example, pointer should be null, could be null, so we should check for like stack isn't equal to null, so we just do it. Otherwise, we just exit, or we throw an exception, or somehow report an error. But generally, if you don't want your function to be called with a null, just use reference. It's pretty much the same thing as pointer. There are differences, but this context, it's better to use copy. Sorry, it's better to use pointers instead of references. Again, so what do you write? I just wrote a simple demonstration on about like simple demo. It's a class. It's a stack of integers. It's pretty simplistic. There is no boundary checking, no error reporting whatsoever. But I just wanted to demonstrate that sometimes it's important to write copy constructors. And one last thing is destructors. So I mentioned that there is constructors, and constructors are functions that okay, I'm not going to talk about destructor. I wanted to show you a funny thing about copy constructors. So let's remove a reference here. Let's copy over it here, right? And like I mentioned, constructors are normal functions that take in an instance of another object. So we could remove const here, and well, const designates constness. Constness class is a very interesting thing. I feel like I should talk about it in depth next time. So we have, and once again the same way. So there is no real change here. What would happen if we take in stack other, not by references? What would happen if? And why the fuck does it say that it's an error? It's not an error. I'm pretty sure that it's a valid C++. I'm not sure though. Okay, maybe not. Maybe I'm incorrect. Let me actually find G++ compiler. I'm pretty sure that's a valid C++, but you shouldn't do this. Grep. How do you define a copy? Okay, I'm going to show you. Basically, it should take either a reference to the instance of the same class, or a const reference. Typically, you should just write this. Just write const reference. And let me know if I should talk a bit about const, because I could explain const to you if it's necessary. So typically const means that we won't be able to modify the object, and we don't really need to modify other. So that's why we take by the const. Sometimes, like in case of auto pointer, which is a type of smart pointer, it's necessary to take a non-const reference, but it's an exception. You should really need this. Typically, it's just const reference. Okay, I'm pretty sure this is valid C++, but let me try compiling with actual G++. Clan is too. His clan doesn't let us to shoot in the foot. Next question. What really changed between plus value? I know people saying one said to value, then shows value, and the other shows value, and then add one of something. Okay, I will answer this question in 5 minutes. And let me finish this demo. I actually want to compile this. Invalid constructor, damn it. I think older versions of a compile did let this. Basically, well, it doesn't really, okay, this code doesn't really make sense, and I think it should, so what I was trying to show you that this should, in my opinion, this should result in an infinite recursion, and the reason why is because we are defining a copy constructor, and copy constructor is just regular functions. Well, they are special functions, but they don't have any special rules for their arguments, and they're defining copy constructors. And when we call this copy constructor, this function, like basically, this should result in infinite recursion, because to copy this instance, we need a copy constructor, so it's going to be called again and again and again. So yeah, this would result in infinite recursion. C++ copy. Luckily, compile doesn't even let us compile the code. So I'm curious about. I feel like I did this before. One time I actually wrote a code like this just to make sure, and I compiled it, and I think it was an infinite recursion, but I'm not sure. Okay, anyway, I wasn't really able to demonstrate it. Yes, you are copying an object in the. You from Ukraine? No, I am from Russia. I'm from Moscow. Yeah, I mean, it doesn't really make sense, because if it was possible, this would result in infinite recursion. Oh, hi, I'm not able to log in with Reddit. What the hell, really? Okay, do other people have problems with logging in? Okay, I don't want to sign off. Okay, let me try it. Maybe it's a Reddit issue. Maybe did it? Sometimes Reddit takes more than 30 seconds to respond to an HTTP request. Okay, I was able to log in, so it's very likely that this is a Reddit issue, but I'm not sure. Could you please try one more time? Okay, so like I mentioned, yeah, you are right. This shouldn't be possible because, well, it doesn't really make sense. Yeah, just wanted to show that copy constructors are just like normal functions, and to this, okay. So you just use const reference other here. Oh, so. Okay, so this is very likely a Reddit issue because, like I mentioned, sometimes it takes more than 30 seconds to complete the authentication request. It gave it 500 on. Oh wow, that's weird. Okay, so there was a question on Twitch. So, copy constructors. Now. Окей, короче, тут все просто. Это есть простой класс tag. Ничего особенного, просто такой небольшой примерчик. Sorry for speaking about Russian, because, well, someone asked me to explain this in Russian. Вот. Класс простой, у него есть пару методов, и, в общем, смысл его в том, чтобы продемонстрировать необходимость копии конструктора, в смысле конструктора копировать. So, okay, speaking English again. Okay, I'm going to answer this quick question about increments. So normally, speaking about integers or similar built-in types, normally and let's create a y. Normally, that's how it works. They both increment a variable. The only difference between plus plus value and value plus plus is the return value. So, right. And let's just print the variable itself. Oh, wait a second. I wrote the same plus plus. Okay, look at that. As you can see, the second line proves that they're pretty similar. They're just increment variable, and the difference is the return value. Basically, this is not a statement, right? This is an expression that has value. It sort of like returns a value, and the value of this expression is different. So plus plus x sort of returns the new value, and y plus plus returns the original value. So here's the difference between plus plus value and value plus plus. There is a way to overload these operators for your own types, so they may work differently, like completely differently. Okay, so one last thing about this class is that there is a memory leak. Basically, what happens to this memory when this function exits? Like I mentioned, it is located on heap, which means that it isn't freed automatically, it isn't deallocated automatically, and so we need to deallocate it manually. And well, how do we do it? Turns out that there is a special function called distractor, which sort of distracts an object. It does something about kind of disassembles it, so it deconstructs it. And let's write it here. Basically, we need to basically distractor is a special function. It's called like that. Okay, let's distract. Again, by default, compiler generates this distractor function, but the problem here is that it isn't profit. So the compiler can call the distractors of data members, and it will do this automatically. But like I mentioned, sometimes it's necessary to do some manual deallocation, and well, we allocated some memory here, so let's deallocate it. So we just call delete, and memory will be deallocated. So let me show this. Wait a second. Compile the wrong code. Okay. So here you can see, after this line, you can see two distractors being called, and these two distractors are this one, the distractor of this object, and the distractor of where is the stack copy? Actually, the destructor of, well, yeah, this object. So you can see copy constructor is called here, right? When we enter this function, then this thing is printed 44, and then the destructor is called here, right before the function exits. After the last statement is executed, but before the function returns its value or exits to the calling function. So it's pretty convenient, right? So we just define a memory destructor here, and then C++ does a lot of stuff for us. It calls it automatically. And again, this destructor, we can see that the size is printed here, stack size, and then at the end of the main function, another destructor is called, and this is the destructor of this object. So, okay, let me know if you have questions about copy constructors or C++ in general. And did I talk about everything I wanted to talk today? I think so. So basically, I just want to answer some questions now and then go and code some tetris. So I will go away from keyboard. Why should constructors be public if it doesn't matter much? It matters a lot. As I mentioned, the difference between public and private is that other classes can't call private methods. Well, unless they're declared as friends. So C++ has a lot of interesting kind of things that complicate. So by default, other classes can't use methods declared as private, but you can declare a class as a friend, then it can use a private methods. So C++ is kind of complicated. There are some rules and there are some exceptions to these rules. So not everything is that simple. So now about being public and private. Okay, let me show you. I can really show this. I can show it really simple. Let's make them private. Actually, by default, the visibility is private, so we don't really have to write private here, but let's write to make this explicit. And as you can see, there is lots of compilation error. So if we go on line 62, it says that calling private constructor of class in stack. So constructors are just normal functions in a way. They're special functions, but they abide pretty much the same rules. So they can also be private, they can also be protected. Yeah. So does it matter much? Yes. As you can see, it matters a lot, and it changes a lot of things. Basically, this program now isn't working. Now you can't compile it. So let's change it back to public. Does it? So the question, another question is, does it make sense sometimes declaring a constructor private? And basically, yes, it makes a lot of sense sometimes. Sometimes people do this. But I guess sometimes there are reasons like you want this constructor to be accessible only for the class itself. I guess sometimes it may be necessary, or maybe you want a friend class to call this constructor. I don't know. Sometimes one specific example when you want to declare a constructor private is when you want to ban copying objects. In fact, C++11 provides a better way of doing this. You can just type delete, but before C++11, the typical way of banning copying was just declaring copy constructor private. So we don't really need this, and let's make this like this. Let's make it private. And as you can see, it's now say I can compile using just terminal. It says calling private constructor plus in stack, and basically it means that you can't really copy it. And sometimes it makes a lot of sense. One of the examples is something like boost unique pointer or standard unique pointer. Both of these classes have no copy constructors. I think that standard library has a class fstream, which is for reading files. Actually, let's make it compile again. So there is fstream class. Well, I have an account in vk.com and facebook.com, but they are like private. I use it for personal stuff. If you want, you can follow me on Twitter. And just or on YouTube or on Twitch. Ooh, good go. I know I have Google Plus, but I don't really use it. Plus Google.com. I don't know. Probably I'm. How do you pronounce VK? I've always wondered. I think you should pronounce it as VK, but in Russian, originally it was named like this. Oops. Original name of vk.com, and we pronounce it as Vkontakte. Okay, G+. I have G+. I don't remember my password though. Oh, but here's my G+. I rarely use it though. So now I need questions. Yeah. So I was talking about copy constructors. Not every class has public copy constructors, and I'm pretty sure that fstreams don't. Right? I'm not sure. Let me check this real quick. Actually, why do I? Yeah. Yeah. Okay. I have been writing too much Python lately. Okay. So we decide we want to copy, and here's what happens. It says a lot of compilation errors, and yeah, basically says that class std ios base has private copy constructor. So sometimes it makes sense to declare the copy constructor private to prohibit copying an object, because we can't really copy an open file, right? It just doesn't make a lot of sense to copy open file. or sometimes you have a, like something like connection object, right? You have a connection to a server and it's represented as some sort of an object, and doesn't really make sense to copy a connection object because you need to establish a new connection and so on. Oh, so okay, I'm going to go away from keyboard and then some tetris development. But Hi, I'm back. So looks like there are no questions, but if you have one during the coding process, let me know. I will be happy to answer them, whether they are off topic or on topic. So what was I doing? Okay, Tetris. Tetris. Time to code some Tetris and Tetris. Where was it? CD. Let's Tetris. 1 plus plus. Tetris plus plus. And again, didn't work. And well, there is like there here that it is. Here is that command. And well, here's what it looks like now. It looks similar to real Tetris, but it's far from perfect. And guess let's code it. So basically, I have class. Oh, I completely forgot that I plan to remove these files from these classes from the main class. I don't feel like there should be a lot of classes inside other classes. Doesn't sound right. Hi, there is a recording available, so if you need it, the recording will be here. So now I'm just starting coding it to code the Tetris. So if you have questions, just let me know. I will be happy to answer them, whether they are on topic or off topic. I will be happy to answer them. So, okay, I'm not entirely happy with this. Oh, damn it. Let me close my main browser so there are no notifications. So, I'm pretty much thinking about refactoring this into some sort of a settings class. I think it would be much better if this is what the hell? But this would be a settings file, settings class. What's next? So I guess let's implement some collision checking. And let's make sure that a figure can be moved through the squares, right? So now it can overlap, overlaps. What worries me is that it looks like there is some weird space here. I don't know why is it here. So let's make sure that field position X. And I'm also not happy that this class square has draw function. Shouldn't be here. Shouldn't be here at all. Okay, draw matrix. I don't get it. I don't understand. J plus offset x, y plus offset y. Yeah, like completely not happy. Field position x, x multiplied by square size, field position y. Okay, let me think about it. Field position x plus x multiplied by field. Okay, let's see draw. Y plus offset x. There is draw matrix window field. Okay, so there is a square that's complete should be near the border. Okay, let's debug using this square, and for some reason it is drawn, it's being drawn not near the border. So let's see. So its border set position is called field position x, field position y. Let's see how draw matrix is implemented. Okay, and by default these offsets are 0. So in C++ function can have default arguments, and matrix ij draw called window and when we call this method, something happens here. Okay, let's print let's also make sure, okay, yeah, std cout x y. Let me check the back questions. So if you can see here, for some reason looks like for some reason it's never called with um, with the first argument being 0. Um, so let's debug it. Let's just add class of set x here. Let's just print this thing. Let's just print here some debug information. Oh, so yeah, it's not a function, it's a simple data member. Oh, wait a second. Okay, it makes sense. Everything, the code works correctly. I just should have defined it this way. So, like this. Yeah. Now it's drawn near the border. Again, it's not perfectly aligned with the border. I mean, I don't like how the border is drawn, but let's not worry about it. This now. Okay, let's remove this. Let's remove this. Kind of feel like the first argument should be X position. Let me check it. I'm pretty sure it's a Y position. Does it look natural to me? Yeah, it's Y position. Well, wait a second. I mean, yeah, why I don't like this. I mean, shouldn't it be? Yeah, okay, let's refactor with this. So it takes so the first argument is void an X position. Okay. So now it doesn't work properly, but that's okay. Let's pass I here, let's pass J here. Okay, let's multiply this by field height, and let's multiply this by field width. So let's see. Okay, now the first position is X and the second position is Y, and to me it looks a more natural order. Now let's add some better collision handling. So we need a better handling of collisions. So to do this, let's basically make sure that let's never get outside of this window. So we have these methods: move figure right, move figure left, and move figure down. And let's basically check have these coordinates, and let's write a function that just got this check figure position. It's going to take int x and int y arguments. Correct figure position. So let's start by simply making sure that no square is ever outside of the field. So what was the interface? So it has a pretty simple interface. It has get square, it has get current state, and we know that every figure is 4 by 4. So let's actually create a constant. Its size is going to be 4. Plus I. So every figure is 4 by 4 thin. So it's 4 by 4 two-dimensional array, and we simply are going to do get square x, y, I, j is occupied. So if it's unoccupied, we are going to make sure that let's make one single condition. So let's check this. Let's make sure that x plus y is less than field width. Let's make sure it's positive or non-negative. Same thing for y. Y plus I is less than field 8. Actually, not less than. Yeah, it's less than, not less than equal. Less than or equal to. And it should be non-negative. Wait a second, should be. Alright, let's check this code and actually we need to reverse this condition. So we are going to return false here. So basically, let's add OR here. Or we could let's add OR here. Let's add OR here. Or here. So we need to inverse this condition. It's more than equal to field here. It's more than equal to field B. So we basically do some boundary checking. And if at the end of the function, let's just return true, because if every square is within borders, then it's correct figure position. Of course, we need to add some collision checking, but for now we are just going to make sure figure stays within the border. And okay, let's if is correct figure position, fig x plus 1, fig y, x minus 1, and y minus 1 here. Okay, let's see. I guess it doesn't work probably because the original position is incorrect. Makes me wonder why. Okay, let's make it 22. In Tetris, the size of the board is 10 by 20, but the first two rows are invisible. And I guess actually let's make it 10 by 20 and let's handle invisible rows later. For now, let's just set fig x to 0, fig x to something like that. Okay. Basically, it doesn't move. Yeah, it can't move outside of the borders, which is great. Which is exactly what we want. So now let's make collision check. Let's make sure that the figure can't pass through squares, right? Is correct figure position. Or so field is just vectors of vectors, so it's suggested two-dimensional arrays. We can simply make sure that x check y plus j. We can check if it's occupied. So if it's already occupied by some square, okay, then it's an invalid move. So let's make sure it works. Okay, it works. Look at this. So now there is a basic collision checking, which is great. Let's commit this. Nice. Let's make sure how to let's check how to write game loop in HTML. So basically, we need something like wow, the rest people are writing some fairly complicated code for handling game loops, and I'm pretty sure we don't need this. Let's just look how to handle time. Let's make the figure move. Let's write a function something like force figure down. And for now, it's going to, and the difference between move figure down is and force figure down is that force figure down is going to be executed when player like runs out of time. So it's going to move figure down automatically, and move figure down is going to be triggered by player actions, by when player presses down. But for now, let's just do move figure down, and let's just make sure that you can move it down. And let's print how much time is elapsed. And actually we can't print it for some reason, maybe because we need we need to call something like s milliseconds. Okay. So here's our clock. It runs steadily, and let's create a constant int tick size, which is going to change which is going to define the speed of a figure. So let's make it 1 second for now. If so it's just larger than tick size, we are going to reset the clock and force figure down. So resetting the clock and forcing figure down. And as you can see, it is now able to move down. Okay, basically now the collision check prevents it from moving down. And if we move it like this, it continues moving, which is similar to what we want. Right, so what we need is just some fancy way of stopping a figure. So let's do this. Let's simple clock handling figure moves down every 1 second. Okay, so let's implement this function. So let's make sure if is correct position, fig x, we are just going to move it down, right? And if it's not correct, we are going to, I don't know what's the proper term, but we are just going to generate a new figure, and we are going to add the previous figure to the field, right? So I don't know what's the proper term of writing figure to the field. I don't know. I can't think of a better name. Okay, I guess let's call it simply void add figure to field, right? Add figure to field. Generate figure. Generate new figure, right? So and here we have, again, these functions should probably be private. So generate new figure. Let me check chats. What are you doing? I'm implementing a tetris using C++ and hi. I'm trying to teach some C++ in the process. So hope you guys find this useful. I really like receiving questions from you. So don't hesitate. Don't be shy. Ask me questions. Tell me interesting things in chat. Okay. So the generating figure is going to generate new figure, and that figure to field is going to simply write it to the field. So we're going to have a similar loop here. The figure get square is occupied. We are going to take this and assign a new square here. This worked. I don't think it did. Use of undeclared variable x. Okay, we have a fig x here and fig y here available, so let's use them. Okay, let's test it. I don't know if it works. Honestly, generate new figure does nothing. So I feel like the previous figure should be able to move. Oh, maybe not. Okay. And let's write a function that generates new figure. Oh, by the way, we need to do collision check here as well, but okay. Generate new figure. Okay. For now, let's just do this. Let's create a figure here. Big X is going to be, I don't know, 0, maybe something like 8. Field with y, sorry, divided by 2. Big Y is going to be, I don't know, 0. So field height, yeah, field height. -4. Again, to do better initial position, hidden rows. Okay. Okay, let's see what happens. Okay, it sort of works. Let's see. Okay, so now the figures basically can stack to each other, and as you can see, collision handling when rotating a figure isn't perfect. And we have a rotate figure, and basically let's add a collision handler, right? So if not, fig is correct figure position, fig X, fig Y, we are going to, well, rotate it back, because why not? Or maybe you should call it something like, okay, let's call it rotate back. So it's going to be this. And let's see. And it stopped working. Stopped working. Just what the hell? Let's see when we call it. Okay, if not is correct position. We need to negate this. Okay. Okay, I have a feeling that it works. Okay, let's generate new figure, and let's add colors to the figure. I'm wondering if there is a way to generate random colors from some sort of a predefined set. And Hmm. Okay, so there is a randomizer class, but now I'm wondering that it's possible to use it in CFML. Okay. So okay, let's just generate it rather simply. Where is it? Class figure. So yes, let's add a color here. Okay. $59. Generate new figure. Okay, when we create a class game, we are going to generate a new figure. By default, it has no default constructor. So let's add default color here. Let's see what happens. I don't know, I don't think it worked. Oh, maybe that's because we don't actually generate a new color. So color and let's use random. Oh, wait a second. It's in the wrong place. Okay, so now the color is random. Now, well, they are only somewhat different, but as you can see, there is a handling of different colors. I think that there should be a predefined set of colors instead of generating completely random color each time, but this, you can see it works. Okay, really nice thing. So it's starting to look like Tetris, which is pretty cool. It's impossible to clear a clear line here, but that's all. That's okay. Yes, you can see the figure. A figure is generated every time. So okay, this actually needs to be handled too. Let's commit this. Let's actually put this to GitHub. What are you doing? Just use color for one form, then you don't need random colors. Oh yeah, maybe. Maybe you're right. I think that's how Tetris has actually implement this. Thanks. So the code is available on GitHub. You can use it. I feel like I should end the stream now because I've been streaming for like I don't know, about 2.5 hours. So the code isn't pretty, and there is a lot of refactoring that should happen in the future. But it's starting to look, but the game is starting to look a lot like a proper Tetris. So here's the code. It's available on GitHub. So yeah. Yep. So let me know if there are questions. We'll wait for like a minute, and then I will end the stream. Thank you for watching. Should be countdown using DuckDuckGo. There was a countdown. Damn it. Okay. Let's wait for a minute. And if there are no questions, I will end the stream. So yeah. So yeah, thank you for watching. I hope you enjoyed it. It's kind of sad that there are too few questions today. I really enjoy receiving questions, answering them. Okay, 51, 52, 53. Okay. Yeah, okay, 1 minute has passed. Thank you for watching. How old are you? I'm 23 years old. So yeah. If you like my stream, please subscribe. Oops, why did I refresh it? I had no real intention of refreshing it. When is the next interview stream? There is no set date. Very likely that there will be a stream somewhere this week, probably Friday, Sunday, or Saturday. I can't really. We don't have a set date, and I actually don't know who whom I'm going to interview, but it's probably going to be one of the Rust developers. And by Rust developers, I mean people who actually develop Rust, the language itself. Yeah. But again, this isn't. I mean, I didn't talk to this person. However, Mike promised me to connect, so I feel like it's there is a good chance that the next interview stream is going to be about that. What's wrong with you, Twitch? Okay, I kind of hate when it just stops loading and responding. Oh, okay. Anyway, okay. So if you have questions, you have maybe 30 seconds to copy and paste them here in the window, and then I will end the stream. By the way, do you have like if you have some ideas about whom I should interview, please let me know. Have been disconnected. That's weird. Have been connected. Let me check this. Okay, it works. But there are some random disconnects. I need to go and fix this. Okay, I guess there are no more questions. And yeah, so thank you very much for watching and bye. Test.